Moving on to the second short concept that is, again, that confuses a lot of students. So let's just look into it, because this should have been taught in O-levels and IGCSE, and unfortunately it's not. So we have to fix these short concepts, because if your basics aren't clear, you won't be able to understand titration curves, which is a piece of cake, frankly speaking, right? And you'll see it inshallah when I teach it to you. But before that, we are slowly and gradually fixing our basics. Now, another basic that I want to fix is the difference between concentration and strength. And this is a common confusion amongst a lot of students. What's the difference between concentration and strength of acids? Please, let's talk about this for a moment. See, the strength of the acid depends on what? How strong an acid is or how weak an acid is. What does that depend on? And you'll enjoy it, inshallah. How strong an acid is and how weak an acid is, what does this depend on? This depends on ionization, doesn't it? If the acid can fully ionize in an aqueous solution, it's a strong acid. For example, HCl, it can fully ionize in an aqueous solution, right? But if an acid can partially ionize in an aqueous solution, it is what? It is a weak acid. Isn't this true? Right? Or if you are a Pearson and Excel student, if the acid can only slightly ionize in an aqueous solution, only very slightly ionize in an aqueous solution, it's basically what? A weak acid. So this is a weak acid and that's a strong acid. So the strength of the acid, please, the strength of the acid does not depend on concentration. This is a common confusion. The strength of the acid depends on the ionization, the extent of ionization. If it can fully ionize, it's a strong acid. If it can only very slightly ionize, it's a weak acid. Done? Now, this is one idea. The next idea is the pH. Right? We know that, and we're going to learn about pHs in a little detail. I'll teach it to you, although that is part of A2 chemistry, but I'll teach you some idea about pH, what pH scales are and how they are made. I'll teach you that tomorrow, inshallah. But for now, just using our O-level IGCSE knowledge, a pH is what? pH basically tells you the concentration of hydrogen ions, right? It tells me the concentration of hydrogen ions, doesn't it? Right? And the more hydrogen ions you have, the lower pH that you're going to have. That's why acids, they normally have a lower pH, because it has higher excess or larger excess amounts of hydrogen ions, excess concentration of hydrogen ions. Done? Now, this is where I need everybody's attention. The pH that you are going to get does not depend on the strength of an acid. No. It does not depend on the strength of an acid. No, sir. The pH depends on the concentration of hydrogen ions. And this is what you should have been taught. Right? What does this mean? The pH depends on the concentration of hydrogen ions. Let me tell you, sir. See, if you take a strong acid and you take a weak acid, which one is going to have a lower pH? Which one is going to have a lower pH? If you take a strong acid and if you take a weak acid, which one is going to have a lower pH? From O-levels and IGCSE, we've learned that stronger acids have a lower pH and weaker acids have a higher pH. Obviously, it's lower than 7, but it's going to be relatively higher, right? So if a strong acid has a pH 1 and a weak acid maybe has a pH of 3 or 4, right? Whatever. Sir, but wait a moment. You literally just told us that the pH does not depend on the strength of the acid, and now you're contradicting yourself. Now, sir, you are saying that a strong acid has a lower pH and a weak acid has a higher pH. Yes, I'm contradicting myself. Why? Because this is what you've been taught in O-levels and IGCSE. This is in fact not true to much extent. To some extent, maybe. I like some extent. No, it's not true to some extent. I'll tell you. There's an assumption that we make when we say this. There's an assumption. And that assumption is not taught to you in O-levels, right? And you'll learn it right now. See, I told you that the strength of the pH is basically the measure of the concentration of hydrogen ions, right? is the measure of concentration of hydrogen ions. The more hydrogen ions you're going to have, the lower the pH you're going to have, right? And normally speaking, if I take the same moles of a strong acid, let's suppose I take 1 mole of a strong acid and 1 mole of a weak acid, which of these two is gonna have a higher concentration of hydrogen ions in an aqueous solution? Obviously, HCl is a stronger acid. It's gonna fully ionize. This is gonna have 1 mole of hydrogen ions in an aqueous solution. This just partially ionizes, or very only slightly ionizes, and it'll have hydrogen ions and CH3COO minus ions, but it'll have not 1 mole of hydrogen ions. It'll be roughly lower than that. It's a reversible reaction. It's a weak acid, right? So it'll be lower, right? And this is what you should have been taught in O levels and IGCSE, which is the idea that, hey, when you say stronger acid is going to have a lower pH and weaker acid is going to have a higher pH relatively, it's because we are making the assumption that, hey, both acids, the stronger and the weaker one, have the same concentration. This is also 1 mole per dm cube. This is also 1 mole per dm cube. So if they both have the same concentrations, obviously the one that is the stronger acid is going to have more hydrogen ions, and the one that is the weaker acid is going to have the less hydrogen ions. And because of more hydrogen ions, this one has a lower pH. It's not because it's a stronger acid, but it's because it has more hydrogen ions. And yes, it has more hydrogen ions because it's a stronger acid, but wait, just give me one moment. This myth will be debunked in a while. And this has lower hydrogen ions, and therefore it will have a relatively higher pH. Higher pH relatively, right? And this has lower hydrogen ions, right? And now let me take you guys on a ride with me. And that ride is the idea that what if I take a very concentrated, listen to this very carefully, I take a very concentrated weak acid, a very concentrated weak acid, right? And then I take a very dilute strong acid. And this is where the idea comes into play. See, I told you that pH does not depend on the strength, please. pH depends on the concentration of hydrogen ions. The more hydrogen ions you're going to have, the lower pH you're going to have, right? Now, we know that a weak acid only partially or only very slightly ionizes in an aqueous solution, and a strong acid fully or totally or completely ionizes in an aqueous solution. That's true. But maybe because the concentration is so much, all the slight ionization resulted in more hydrogen ions. And this concentration was so dilute, I took such a dilute concentration of a strong acid that it actually gave me, it fully ionized. It was a strong acid, it fully ionized, but since the concentration was so low that at the end of the day, I also got the lower number, the lower concentration of hydrogen ions at the end. So then which one is going to have a lower pH? Please don't say this is a stronger acid. No, this is a weak acid and that's the strong acid. This is strong. Strength has to do with ionization. But now I'm asking about the pH. Which one would have a lower pH? Sir, it's very likely that this fella right here, this fella, I will make a star right here, this fella right here, it's very highly likely that this fella has a lower pH. Even though it's a weaker acid, but since the concentration of hydrogen ions is now more because you've taken a very concentrated weak acid, and when you compare it to a very dilute strong acid, you realize that the concentration of hydrogen ions here is more, although it's only very slightly ionized. But since you have the higher concentration here, at the end you also ended up with higher concentration of hydrogen ions. So this is what needs to be crystal clear in your brains, that the strength of an acid depends on ionization, whereas the pH does not have anything whatsoever to do with the strength. Nah. They're only partially related to each other, very partially. Because if you take the same concentration of strong acid and weak acid, then and only then you can compare the two. And even then I'm looking at the hydrogen ions. I'm not looking whether it's strong or weak. I'm looking at the hydrogen ions. And it's likely that the stronger acid, if they both have the same concentration, the stronger acid gives me more hydrogen ions, so I have the lower pH. But it's also very, 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 very important to understand and realize and appreciate the fact that if you have a very concentrated weak acid, it can actually even have a lower pH than a very dilute strong acid. Got it? Done? I hope this concept is now crystal clear in your brains that strength of the acid has to do with ionization, whereas the pH of the acid has to do with the concentration of hydrogen ions. Crystal clear. Great. Now, third concept that I want to get crystal clear for you guys. And that is, see, for example, if I take HCl and I take CH3COOH. That's the third concept I want to clarify. Sorry. Why am I stuttering? I took HCl and I took CH3COOH. One is a strong acid, one is a weak acid. Now, if I take the same concentration of strong acid and weak acid, for example, I take 0.1 mole per dm cube of strong acid and I take 0.1 mole per dm cube of weak acid, they both have the same concentration, right? And this is a strong acid, will ionize completely. This is a weak acid, will only slightly ionize, right? And therefore, this will have more hydrogen ions. And therefore, this fella is going to give you a lower pH because of the more hydrogen ions. And they both have the same concentration. That's the reason why I can compare the two, right? That's what you used to do in O levels and IGCSE even. Now, there's also one more concept that you guys may think to yourself. Sir, what about products? If I react these two with a base, which one would give you more products? If I react these two with a base, which one would give you more products? Let's suppose I react both of them with NaOH plus NaOH. Which one of these would give me more products? Hanji, this is the last concept. And these are very important concepts for MCQs. I know most of you are going to get it wrong. Because you are never taught this way. Hanji, which of these two are going to give me more products? Is HCl going to give me more products or is CH3COOH going to give me more products? Remember, keep in mind, one is a stronger acid and one is a weaker acid. Hanji. Yes. Hanji. Shabash. Do it. Anybody? Guesses? Wild guesses. Wild guess. Sir, HCl will give me more products. Awesome. That's absolutely, yeah. Sir, CH3COOH is going to give me more products. Awesome. That's absolutely. Both of them are incorrect. The reason is they're both going to give you same products. Please use your brains. Up until O levels and IGCSE and up until AS level even, when you guys used to do moles and stoichiometry calculation, use your brains. Have you ever thought of a strong acid and a weak acid when you were performing moles and stoichiometry calculations? Have you ever thought of a weak acid or a strong acid when you used to perform mole and stoichiometry calculation? This is my question. Have you ever thought of this? Or you were just given, this is the volume right here. And let's suppose that's the same volume. You are given volume and concentration. You used to figure out the moles of acid. And then you used to use the balanced equation to find the moles of the product, Have you ever considered a strong acid and a weak acid when figuring out the moles of products? Absolutely not. Since O levels, since A levels, we have not done this. We have never ever done this. No, we have never done this. And the reason, I'll tell you the reason. It's not because the moles are the same, so the product is the same. No, I'm comparing these two. I don't care about the moles or the product. I want to compare these two. The idea is not this. The idea behind it is very, very important. It's because, see, if you have a strong acid and you have a weak acid, and also I hope I have like a diagram for it. I just use the same old diagrams. Wait. If I have a strong acid right here, this is a strong acid, right? And if I have a weak acid right here, and this is where the aha moment will hopefully come into play. If I have a strong acid, this is my strong acid, right? Let's think of this as HCl. And this is my weak acid. Think of this as CH3COOH. This is my strong acid. It's not just because their moles are same. No. It's also because, and this needs to be crystal clear, that when a strong acid reacts with an alkali, these hydrogen ions are basically what are reacting, right? Hydrogen ions or the A minus ions, they are reacting. The sodium ion is going to react with the A minus ions, and the OH minus ions are going to react with the H plus ions. Is going to give you H2O, and one is going to give you like NaCl maybe, right? That's the salt. One is going to give you the salt, and the other, the OH minus in the alkali and the H plus, is going to give you water, right? Now, if it's a weak acid, we've learned the idea, we've learned the definition of Bronsted-Lowry. What does Bronsted-Lowry say? Shabash. Bronsted-Lowry acid is what acid? Bronsted-Lowry acid is a proton donor. Isn't that true? Bronsted-Lowry acid is a proton donor. So let's suppose I have NaOH, right? Now, although it's a weak acid, but the idea is that you have the same concentrations, this concentration and this concentration. If you have the same concentrations, that means you have the same particles, don't you? Same concentration means if I have 0.1 mole per dm cube of an acid, be it weak acid or be it strong acid, what does that mean? That means in 1 liter or 1 dm cube you have 0.1 moles, and 0.1 moles you can convert it into particles, right? 0.1 into 6.022 into 10 is power 23. So you effectively have the same number of particles for weaker acids or stronger acids. Doesn't really matter. You have the same number of particles. But Bronsted-Lowry has taught you this, that acids are what? They are proton donors. So even if they are in the form of HA and they have not completely ionized, you know that the moment an alkali comes here, this HA will do what? This HA will donate a proton, and that is the reason why the products that you get are the same, because products, again, they do not depend on whether the acid is strong or weak, rather they depend on the concentration, the number of particles. They depend on the number of particles of acid, right? And because the concentration is the same, the number of particles of acid in a strong acid and a weak acid are both same. And these HA molecules actually also react with NaOH. So effectively, if you look at both these reactions, in both the cases, in this case, they are reacting with NaOH, the hydrogen ions and the A minus ions, and in this case, the A minus and the HA, all they are reacting with, right? So either you split them and react it, or they react directly like this and act like a Bronsted-Lowry acid. They are both the same thing. So the number of products has nothing to do with whether the acid is strong or weak. It has to do with the concentration of the acid. As long as both the acids have the same concentration, sir, whether it's a strong acid or a weak acid, the products that are going to form are going to be the same as far as the moles are concerned, right? Because we know that it's the particles which react. It's the particles which react, be it in the form of ions or be it in the form of molecules, right? So that's the actual idea behind it. So which one would give me more products? Absolutely, you dumbo jumbo, neither. They're going to both give you same products because they both have the same concentration, which means they both have the same particles, right? It doesn't matter if these particles are largely in CH3COOH form. It doesn't really matter, because even this molecule is going to react with the alkali. Even this molecule is going to react with the alkali, and it's going to act like a Bronsted-Lowry acid, which is a proton donor. It doesn't necessarily have to ionize completely to react. It can also react in the form of a molecule, right? So understand that if you have the same concentration of two acids, and one is a strong acid and one is a weak acid, the products does not have to do anything. It's not related to strong or weak. It has to do with concentrations. And that's the last concept what I wanted to teach. So I've taught you guys 3 concepts in these 2 classes effectively. Number uno concept that I taught you guys was the idea of endpoint or equivalence point. That it has to do with what? Equivalence point. It has to do with what, sir? It has to do with the moles, the stoichiometric moles, not the volume. The volume can be up and down. It doesn't really matter. It must be in the ratio of stoichiometric moles in order to react and finish each other off, right? Secondly, what I taught you in the last class was the idea of strong acid, or in this class, the idea of strong acid and weak acid, and that it has to do with ionization. It has nothing to do with the hydrogen ions. And then I talked to you guys about pH, which has to do with concentration of hydrogen ions. It's not necessary that a strong acid will always have a lower pH. Now this clarity should be there. Strong acid normally has a lower pH than a weaker acid, because if you take the same concentration of strong and weak acid, the strong acid will give you more hydrogen ions, and therefore the pH depends on the concentration of hydrogen ions. If you have more hydrogen ions, you're going to have a lower pH, right? But it depends on concentration of hydrogen ions. Don't make yourself be rote learners thinking that, oh, strong acid will always give you a lower pH. That's incorrect. If it ever comes in the MCQ, will strong acids always give you a lower pH? No, not necessarily. Because if you take a very strong weak acid and a very dilute strong acid, maybe the very concentrated weak acid, maybe that very concentrated weak acid gives you a lower pH than a very dilute strong acid, right? So strong and weak acid has to do with ionization. pH has to do with the concentration of hydrogen ions, nothing to do with strong or weak. And the last concept which I taught you guys is that the products that you are going to get depends on what? Depends on concentration. It does not depend on the strong acid or weak acid. It depends on the concentration of strong acid and weak acid. See, the more particles you're going to have, the more products you're going to have. But if you have the same number of particles here, see, both are 0.1 mole per dm cube, 0.1 mole per dm cube. Both have the same number of particles. So the product that's going to form is going to be the same, provided they are my limiting reactant, obviously. You'll use this assumption right here. But yeah, that's the idea. Dimag khola thoda sa? Brain opened or no? Brain opened?